Welcome back to another math video with Mrs. Hill. Today I'm going to show you how to convert fractions and decimals. Make sure you write down all the notes and examples I give you and bring those notes to class tomorrow. Let's start with 7/8. You may remember some of this from the past, but let's review how to write 7/8 as a decimal. Method number 1, you would simply divide. 7 divided by 8. So numerator divided by denominator. Add a decimal point and a 0 to begin with, because 8 doesn't go into 7. 8 goes into 70 8 times, because 8 times 8 is 64. The remainder is 6. And we're going to keep dropping zeros until we figure out if it is a terminating or repeating decimal. Sometimes it goes on forever. Let's take a look at this one. So now I'm going to divide 8 into 60, and that is 7 times, because 7 times 8 is 56. Remainder 4. And when I bring down one more 0, I see that 8 goes into 40 exactly 5 times, because 5 times 8 is 40. So once I have a remainder of 0, I am finished. My decimal is a terminating decimal. That means it ends, it terminates. 0.875 or 875 thousandths. That is 7/8 as a decimal. Method number 2, use a calculator. Obviously, I don't want you to use a calculator to figure out the work, because I want to practice division. But you may check your work with a calculator, and that would simply be, don't forget to punch in the numerator first. 7 divided by denominator equals 0.875. If you have one of those fancy calculators, scientific or graphing, you can actually punch in the fraction, 7/8, and it'll convert it for you. So I'd like you to try some. These are pretty simple terminating decimals. Why don't you try these two? Pause the video, unpause when you're finished. 4/5 and 3/16, and then we'll go over them. Right, let's go over how to change 4/5 to a decimal. I hope that you may have remembered an easier method, which I'm going to go over in a few minutes. But let's go ahead and divide, because that's what I just showed you. 4/5 is 4 divided by 5. 5 doesn't go into 4. 5 goes into 40 exactly 8 times. So 4/5 is 0.8 or 8/10. All right, this one's a little bit different, a little bit harder. So 3 divided by 16. One of the most common mistakes when turning a fraction to a decimal is kids divide the wrong numbers. So they end up putting the denominator on the inside. So remember, the numerator becomes your dividend. The denominator becomes your divisor. All right, so 16 goes into 30 just one time. And the 0 there. When I subtract, I get 14. I bring down a 0. Let's see, 16 into 140. Let's take a guess here. Let's try 8 times. 6 times 8 is 48. 1 times 8 is 8, and 4 is 12. And looks like that was close enough. 8 times 16 is 128. And my remainder is going to be 12. You can do the regrouping. Hopefully you're just checking your work at this point. And it's still going. So now I'm going to divide 16 into 120. Well, I know it goes into 120 8 times, so it must be 7. Let's check what 16 times 7 is. 112. 112. Subtract, and I get 8. And this one's going on for a little while, but I'm going to persevere with it. Now divide 16 into 80, and when you check 16 times 5, 6 times 5 is 30, 5 times 1 is 5, and 3 is exactly 80. So this one took a few minutes, but I was able to figure out that it is 0.1875. Hope you saw my methods for dividing. I had to guess and check, because I had a 2-digit divisor. I don't know my 16 times table, so I had to do a little guessing and checking on the division. All right, let's look at some more examples of writing fractions as a decimal. Sometimes the fractions do not, the decimals do not terminate. Sometimes they repeat. That means the numbers keep on going and going. Let's look at some examples. Make sure you're writing these down. 5/12. So 5 divided by 12. Add my decimal and my 0. 12 doesn't go into 5. Goes into 50 4 times because 4 times 12 is 48. Remainder 2. Bring down a 0. 12 goes into 20 just 1 time. 1 times 12 is 12. Remainder 8. Bring down another 0. 12 goes into 86 times. 6 times 12 is 72. And here I'm noticing a remainder of 8 again. If I bring down another 0, 12 is going to go into 86 times again. And I'm going to have the same remainder over and over. So the 6 repeats. So 5/12 is actually 0.416. And I'm going to put a bar over the 6 to show that it repeats. Make sure you use bar notation if a number repeats. Okay, here we have an example of a negative fraction, 2/11. So I know my answer is going to be negative 0 point something. And I'm just going to divide as usual. 2 divided by 11. I'm going to divide 11 into 2. 11 goes into 20 one time. Remainder 9, bring down a 0. 11 goes into 90 8 times because 8 times 11 is 88. Remainder 2. And, oh, look at this. I'm back to where I started. 11 goes into 20 one time. And I'm going to keep on getting the same thing. 20, 11, 90, 88. So it's going to be 0.181818. So in this situation, I'm going to put the bar over the 1 and the 8 because both of those digits repeat. Notice this one, I only put the bar over the 6 because my 4 and my 1 didn't repeat, only the 6. So only put the bar over the numbers that repeat. Okay, I want to show you, before I have you practice some, again, go back, rewind the video if I talked too quickly or went too quickly, and you can look back over those examples if you need to see that more slowly. I want to show you that it is very helpful for you to memorize some, what I call, easy fraction decimal equivalent. Hopefully you already know that 1/2 is 0.5. If there's any of these that you don't already know and have memorized, I would strongly encourage you to write them down, maybe even on flashcards with a decimal on one side, fraction on the other, so that you can practice and memorize them as soon as you can. If you already know them, you don't need to write them down. 1/2 is 0.5. I think most of us know that by now. 1/4, 1/4, that's, I don't think of money. It's like 25 cents, 0.25. 3/4 is 0.75, like 75 cents. 1/4, 1/4, 3/4, 3/4. All right, a few other easy ones. The thirds. The third, 1/3 is 0.33333. Check it out if you want to see. 1 divided by 3. When you do 1 divided by 3 to find the decimal equivalent for 1/3, you'll see you're going to get 0.3 repetitive. So 2/3 is 0.6 repetitive. So these are some easy fraction decimal equivalent that you might want to commit to memory if you haven't already. A few minutes ago we saw a fifth. I think we saw, was it 2/5 or 3/5? It was one of the fifths. And fifths are pretty easy to memorize as well. 1/5 is the same as 2/10, isn't it? If we multiply by 2, which as a decimal is 0.2. So if 1/5 is 0.2, 2/5 is 0.4, 3/5 is 0.6, 4/5 is 0.8. Look, 2/5 is equal to 4/10. See, 5 times 2 is 10, 2 times 2 is 4. So these are pretty easy. 1/5, 2/5, 3/5, 4/5. I do not expect you, nor would I want you to divide every single fraction to convert it to a decimal. There are definitely some shortcuts we're going to be talking about over the next few days. Memorize these ones. If you get something you haven't memorized, certainly you can divide it. We're going to talk about other strategies. And then, obviously, if there's 10 on the bottom, then all you have to do is write the numerator in the tens place. If 100 is on the bottom, write the numerator in the hundredths place. Okay? So, let's say you have something like 4 tenths. What would that look like as a decimal? 0.4. Well, what if you had 4 hundredths? How would you write that as a decimal? 0.04. Okay, one more. What if I had 24 hundredths? How would I write this as a decimal? The last digit goes in that hundredths place, which is right here. So 0.24. Right, there's one we didn't talk about, 5/6. I don't think this is necessarily an easy fraction. Certainly memorize it if you can. 5/6 is 0.83333. I wouldn't have added that to an easy list of fractions to memorize, but it's there, so you can memorize it if you want to. Want to finish with 2 real-life examples for you, and of when you might want to convert fractions to decimals. Let's take a look. Look at this first food example here. According to the USDA, the U.S. Department of Agriculture, teenage boys should consume an average of 2,700 calories a day. That's a lot of calories, boys. About 360 calories should come from milk. I think that's actually changed in recent years. It should come from protein sources. Milk is a good protein source. To the nearest hundredth, what part of a teenage boy's total calories should come from milk? Okay, so we've got 360 should come from milk, and they're supposed to consume 2,700 calories per day. So 360 from milk, 2,700 for the whole day. If we want to figure out what part this is, we could write it as a fraction in simplest form, or we could write it as a decimal. One strategy I can use here is I could, instead of having to divide 360 by 2,700, I can simplify this fraction. Simplifying a fraction definitely makes the problem simpler, because then we'll have smaller numbers to work with. Let's see. First thing I can do is I can divide by 100, cross off those zeros. Then I would have 36 over 270. Do you see a common factor for both of these? Yes, 9. We can divide by 9. So 36 divided by 9 would give me 4, and 270 divided by 9 would give me 30. Okay, I just made the problem a little easier for myself. Now I only have to divide 4 by 30 instead of 360 by 2,700. Okay, so now I can convert this fraction to a decimal. So 30 doesn't go into 4. 30 goes into 40 one time. Remainder 10. Bring down the 0. 30 goes into 100 3 times. 3 times 30 is 90. Remainder 10. And look what's happening here. I'm going to get a repeating decimal. 30 is going to go into 100 3 times again with a remainder of 10. So it looks like it's 0.13 repetitive. So if I were to write this as a fraction, the teenage boy's total calories should come from milk is about 0.13, or 4/30 of their total calories. All right, I would like you to try this one problem on your own and bring this problem to class tomorrow. We'll go over it then. Let me read it to you. In a recent Masters tournament, Zach Johnson's first shot landed on the fairway 45 out of 56 times. To the nearest thousandth, what part of the time did his shot land on the fairway? All right, go ahead and use whatever strategies you can to come up with that fraction as a decimal. All right, great listening. Bring all those notes and this example to class tomorrow, and I'll see you then.